Okay, it says, first of all, it says a cylinder. So I'm going to draw a quick picture just because visuals always help. There's my radius. Okay, there's R. And then we have our height. So our height is going to be this guy right here. H equals R equals. Okay, the height and the radius are changing. Okay, that means we probably will have a dr dt or an r prime, however you want to write it. I like using the dt. Okay, so we probably have a rate at which the radius is changing and a rate at which the height is changing. Okay, so it says the height is increasing. Increasing, that's an important word because that means we're positive at a rate of 3 meters per minute. So we have 3 meters per minute. Make sure you put your labels. When the height of the cylinder is 8 meters, so the height is currently 8 meters, and the radius is 2 meters, the volume is not changing. Okay, so dv dt is 0 because it's not changing. How fast is the radius decreasing? Wait, oh, the height is increasing. Oops, I put this label wrong right here. That's not, there you go. Okay, so it says the height. The height is increasing. Okay, we got the 8, we got the 2. The volume is not changing. How fast is the radius decreasing? So this answer should be a negative in meters per minute. Okay. Now it's saying decreasing right here, and so it's not going to make my answer negative. Okay, it's just going to say it's decreasing at a rate of 6 or decreasing at a rate of 3 pi, whatever it might be. So you don't have to have a negative on your final result. All right, so they give us an equation too. They give us an equation that relates the volume, the radius, and the height. So if you didn't know that formula, booyah, there it is. And so I'm going to take this volume and take the derivative of this formula so that we can find out how the dr dt and the dh dt relate to each other. So the derivative of this function with respect to t. The derivative of v is 1, and then we multiply it by dv dt, which we know is going to be 0. And then for the second part, we have two functions multiplying to each other, the radius and the height. Those are both functions of t. Okay, so when I take the derivative of the first one, it's going to be 2 pi r dr dt. Because of the chain rule, that's why you have to write dr dt. And then multiply that by h. Plus, now let's take the derivative of the h. Let's write out the first part. And then the derivative of h is 1. And then we have to multiply that by dh dt. And there you have it. Now we just have to plug in stuff. Let's plug in all the numbers that we know here. We know the 2, the 8, and the 3. So, oh, and we know 0. Let's plug 0 in right there. We have 2 pi r. Nope, we know what r is. R is 2. So I'm going to plug in 2 right there. dr over dt is what we don't know, so I'm going to leave dr dt right here. And then we have h, which is 8, plus 2 squared, or pi 2 squared. Don't need to write times 1. And then dh dt is going to be 3. So we have 2 times 2 times 8, so that's 4 times 8, which is 32 pi dr dt, plus, okay, we have 4 times 3, which is 12, so we have 12 pi, equals 0. Solving for dr dt, let's move the 12 pi over, so we have negative 12 pi equals 32 pi dr dt. dr dt equals negative 12 pi over 32 pi. The pi's cancel out, and now we have 12 over 32, which simplifies. We can divide the top by 4 and the bottom by 4, so we get negative 3 over, that would be 8. So negative 3 over 8. So the answer is 3/8. Again, we don't have to have a negative on our answer because it was already said that we're decreasing. So we're decreasing at 3/8. 3/8. Oh, what's the label for that? They didn't even label it. Meters per minute. And there you go.